Hello everyone, this is Yogesh Langivar. I welcome you all for a series of a concrete technology lecture. At the end of this particular session, you will get to know about the mix design process by IS 10262 2009. Contents of this particular session are introduction, what is mix design, mix design by IS 10262 2009. We know that the concrete consists of a various ingredients like cement, sand, coarse aggregate, water. If it is required, we can use the admixture. I'm not going into the detail of the uses of admixture in this particular session because the uses of admixture I already discussed in my previous session. The concrete in the homogeneous mixture consists of a cement aggregates, which are of two types, fine aggregate and coarse aggregate and water. Mixed design. It can be defined as the process of selecting the suitable ingredients of a concrete. There are various ingredients are there in a construction industry, but the concrete is consists of a ingredients like fine aggregate, coarse aggregate, water, and cement. Cement is used as a binding agent. The uses of the flash, the uses of the fibers, and the admixture. It is totally depend upon the requirement. So, mixed design can be defined as the process of selecting the suitable ingredients of a concrete and determining the relative quantities with the object of producing a concrete of a required strength, durability, workability with economy. As possible, it is called as a mixed design. So, mixed design is not only selecting the ingredients of the concrete, but also we have to achieve our objective in terms of strength, durability, workability, and it should be of economical. So whatever the mixed design which we will prepare for the required the concrete, it should be having a very good strength, it should be durable, it should achieve the workability, and the very important one, it should be of economical one. Now, as far as the mixed design by IS 10262 2009 is concerned, we have to take or we have to collect the certain data. Or we can say we should have this particular data. So this data required following parts. First one is grade designation. What grade of concrete which you are going to prepare? That is very, very important. As per the IS code is concerned, up to the M20 grade of the concrete, mixed design is not required. If we go for higher grade of a concrete than M20, then we have to go for a mixed design. So the very first step is grade designation. Second step is, or the second data which is required is the type of cement. In the industry, various types of cements are available, like PC, PPC, colored cement, rapid hardening cement. So the type of cement is again plays a great role. So it should be known to us. Third is the maximum nominal size of an aggregate. So depending upon the requirement and in IS code also it specifies what should be the maximum nominal size of an aggregate. Minimum cement content, that is the fourth part which we should have. Maximum water cement ratio. The range of water cement ratio is 0.45 to 0.6, but it is we have to pick in between 0.45 to 0.6. So the maximum water cement content ratio should be available with us. Workability. It plays a great role in a concrete and it also related to the strength of concrete. So we should have the workability value too. There are various exposure conditions. We are mentioned in the IS code IS 456 in table number 4 and table number 5. So we have to choose the exposure condition also. Maximum temperature of a concrete at the time of placing is again plays a great role. So we should have the data of that also. Methods of transporting and placing. Whether we are transporting the concrete by transit miller, whether we are placing the concrete with the help of a concrete pump, that data should be available with us. According to that, the water cement ratio changes, or we can say the water cement ratio plays a great role in it. Early age strength requirement. If required, type of aggregate, then maximum cement content that should be available with us, and whether an admixture shall or shall not be used. See, the case of admixture is totally dependent upon the requirement. If you want the concrete should get a strength very early, then we can use the admixture. If you want to reduce the water cement ratio, then in that case also we can use the admixture. So the uses of admixture is totally depend upon the requirement. Next, these are the targets, or we can say the steps which we have to achieve as per as IS 456 2009, IS 10262 2009 method is concerned. In the IS 10262 2009, all the steps are given in detail. So the very first step is target mean strength. Now target mean strength is equal to the characteristic strength plus K into S, where K is equal to 1.65 and S is nothing but the standard deviation. The next part is the selection of the water cement ratio. Third part is the determination of the water content. The contents of water plays a great role as far as workability is concerned. Next part is the calculation of the cement content. At the end, we have to calculate the mass of a fine aggregate and coarse aggregate. The very first one, that is the target strength for a mixed proportion. We should have the value. We should decide the grade for which we are preparing that mixed design. Up to the M20 grade of a concrete, mixed design is not required. But when we go above the M20 grade of a concrete, then we have to go for a mixed design. So I have mentioned here the formula. F dash Ck is equal to Fck plus K into S, where F dash Ck is nothing but the target mean strength, which is equal to the characteristic strength plus constant into standard deviation. The value of K is 1.65, whereas the value of S is changes. It is from 3.5 to 5. Now F dash Ck is nothing but the target mean strength, and that should be at the 28 days. FCK is nothing but the characteristic strength at 28 days. Now let us consider that we are doing the design for M30 grade of a concrete. So here F dash Ck is equal to 30 plus 1.65 into standard deviation value. So we will see the standard deviation value for M30 grade of a concrete in the upcoming slide. Now this is the value of standard deviation. For M10 and M15 grade of a concrete, the assumed standard deviation is 3.5, whereas the value of standard deviation is equal to 4 for M20 and M25 grade of a concrete. But when we go beyond M25 grade of a concrete, the value of standard deviation increases and it is 5. Next part is the selection of the water cement ratio. The different cement, supplementary, cementitious material and aggregates of a different maximum size. It consists of a grading and surface texture, shape and other characteristics. May produce a concrete of a different compressive strength for the same water cement ratio. If we consider OPC, if we consider PPC, if we consider the cementitious material and aggregate of a different maximum size, okay, it may be of a 10 mm, it may be of a 12 mm, it may be of a 15 mm, or it may be of a 20 mm. Now grading plays a great role in it. Whatever the aggregates which we used in a construction or which we use in a making the concrete should be well graded. The surface texture also plays a great role. The shape, whether it's a angular, whether it's a flaky, whether it's a elongated, it also plays a great role in it. And other characteristics may produce a concrete. Now, if we changes this context, whether it's a cement, whether it's a coarse aggregate, okay, so it affects the concrete. Okay, and if we take the same water cement ratio for a different, let us consider OPC and PPC and different size of aggregate, so it affects the concrete. Therefore, the relationship between the strength and free water cement ratio should be preferably be established for the material actually to be used. Now, this is the maximum free water cement ratio and with a different exposure condition. If we go for a mild exposure condition, the maximum water cement ratio is 0.55, whereas for moderate it is 0.5, for severe it is 0.45, for very severe it is 0.45 again, and for the extreme condition, the value of maximum free water cement ratio is equal to 0.4, and this data of maximum free water cement ratio is given in the IS 456 2000 in table number 5. Now, this is the maximum water content per cubic meter of a concrete for a nominal maximum size of a aggregate. Now, we can consider the maximum size of aggregate of 10 mm, 20 mm and 40 mm, and depending upon the maximum nominal size of aggregate, the water content changes, and that water maximum water content is in term of a kg. If we go for a 10 mm, then the water content is of a 208. If we go for a 20 mm, then the water content is a little bit reduced, that is 186 kg. If we go for a maximum size of a 40 mm, then water content again reduced to 165. Here we have to take care that these quantities of mixing water are for use in a computing cementitious material, and these are contains for trial batches. Okay, so we have to fluctuate or we have to change the water cement ratio. Third one is the selection of the water content. The water content in a table 2 is for angular coarse aggregate, whereas 10 kg of water should be reduced for subangular aggregate, whereas 20 kg of it water should be reduced for a gravel with some crushed particle, and 25 kg or we can say the liter of water should be reduced for rounded gravel. Now, based on the slump value also, the water cement ratio plays a great role. Now let us consider that if the slump value is in between 25 to 50. Okay, beyond the slump value more than or whenever the slump value is more than 50 mm, then increase 3%. Increase 3% for every additional slump of 25 mm. Now, when this table represents the slump value of 25 to 50, but whenever the slump value is more than 50, then we have to add 3% more water than that is given mentioned in the table. Now, water content for admixture. Whenever we use the admixture, the water content should be reduced. Okay, 5 to 10% for water reducing admixtures and 20% for a superplasticizers. Means when we use water reducing admixtures, in that case, the main content of water should be reduced by 5 to 10%, and that reduction goes to 20% if we use the superplasticizer. Now this next part is the calculation of a cementitious material. It consists of a calculation of a cement, and the cement content is given by the formula water content divided by water cement ratio. Calculate cementitious material from the water cement ratio. and the quantity of the water per cubic, that is nothing but the water content. And we have to check it from durability point of view also. We have to select the higher value, and that is as per the IS 456. So cement content is equal to the water content divided by water cement ratio. Now, this is the estimation of the coarse aggregate proportion. These aggregates are of a different zone, that is zone 1, zone 2, zone 3, and zone 4. Depending upon the nominal maximum size of aggregate and depending upon the zone also, the value, or we can say the volume of the coarse aggregate per unit volume of a total aggregate for a different zones of a fine aggregate. Okay, that is mentioned in this particular table. Whereas the content of fine aggregate is always equal to the 1 minus content of a coarse aggregate. After that, we have to go for an estimation of the mixed proportion. Volume of a cement, volume of a water, volume of a admixture, and volume of a aggregate. So volume of cement is equal to the mass of cement divided by the specific gravity of a cement. It should be multiplied by 1 by 1000. After that, we have to get the value of the volume of the water. So the volume of water is equal to the mass of water divided by the specific gravity of the water multiplied by 1 by 1000. After that, see, this particular step is totally depend upon the requirement. Okay, so volume of admixture is equal to the mass of chemical admixture divided by specific gravity of a chemical admixture, and again it should be multiplied by 1 by 1000. At the end, we have to get the volume of aggregate. So volume of aggregate is equal to 1 minus volume of cement plus volume of water plus volume of admixture. At the end, we have to calculate the mass of coarse aggregate and mass of fine aggregate. So mass of coarse aggregate is equal to VA multiplied by volume of coarse aggregate multiplied by specific gravity of coarse aggregate, and it should be multiplied by 1000. Likewise, we have to calculate the mass of coarse aggregate also. Mass of coarse aggregate that we have already seen. Now the mass of fine aggregate, which is equal to BA into volume of fine aggregate multiplied by specific gravity of fine aggregate multiplied by 1000. So likewise, we have to go for mixed design process. In the next session, I will take a complete mixed design of a M30 grade of a concrete. Till then, thank you.